Hello everyone, myself Aditi, and today I am back with LeetCode's another daily challenge problem. So today we are going to dive into a coding problem that involves working with nested lists of integers. So let's break down the problem step by step to understand what we are trying to achieve. Okay, so let's first talk about nested lists. Okay, so what is a nested list? So in order to understand, imagine a list that can contain both numbers and other lists. So you can have a list within a list and within that a list. There might be more lists or numbers. So it's like a Russian nesting dolls. Okay, it's like a set of Russian nesting dolls but with numbers instead of dolls. Okay, so in this question our goal is to create a program that creates or that helps us navigate through these nested lists and extract the numbers. So we just want to flatten the structure so we get a single list containing all the numbers in the correct order. Okay. So to accomplish this, we are going to create a special class called NestedIterator. This class will have methods that allows us to go through the nested lists and retrieve the numbers one by one. Okay, so basically there are two main methods you can say. One is next, another one is hasNext. The method next will give us the next integer in the nested list, and the method hasNext checks if there's another integer available. Also, as you can clearly see, they have provided us with some kind of interface. So let's talk about why the interface in this code is so crucial. And first of all, it serves two key purposes that enhances the code's flexibility and maintainability. Okay, so first of all, the interface provides a clear set of rules while interacting or for interacting with nested integer objects, and it just hides internal complexities, making the code more manageable. It is like using a remote control without needing to understand how the device works. Okay, also this interface allows the code to seamlessly handle different types of nested integer objects. Okay, it doesn't matter how they are built internally, as long as they follow the interface rules, the code can work with them. The conclusion is, this interface acts as a universal language, enabling our code to interact with various nested integer objects effortlessly. And it's a powerful tool for adaptability and simplicity in our code. So let's consider the example given in the question. Here input list or the input nested list is given as this and the output is this. Okay, so the explanation is by calling next repeatedly until hasNext returns false, the order of elements returned by next should be this. Okay, to understand the example better, let me tell you let me explain it to you with the help of some kind of diagram. Okay, so basically in the input you can see a nested list is given. Suppose in a list you have a list again that contains 1 and 2, then you have a integer, and then you can see another list. Okay, so since in the end as your output you have to return a flattened list, right? You have to return directly the integers within a list. Okay, or you can say you just have to return an array of integers in the end. So the nested list becomes 1, 2, 3, 4, 5. You can clearly see you will first of all call the individual elements, you can say, present inside the nested list. Okay, within this whole list you can clearly see there is one list present which is 1, 2. Then there's an integer, you can see that is 3, and then there's another list of integers which is 4, 5. Okay, and then repeatedly you will be calling the list to get your integer values. As long as you don't get all the integer values, you will have to keep calling the next function repeatedly. That simply means that, what does it mean? It means you are using recursion here. Okay, recursion is being used here in order to get the integer values in the end. Okay, I hope the example is clear, and then in the end you have to return a flattened list. Okay, so let's start our implementation. Okay, so first of all, what are we going to do? First of all, we will initialize our nested iterator class. Okay, so first of all, you can clearly see there is a nested iterator class that implements the iterator of integers. You can say you have just started by creating a class, and it is just designed to help us iterate through a nested list of integers. And when we create an instance of this class, we need to provide it with a list of nested integers. Now, to efficiently navigate through these nested lists, what are we going to use? We are going to use a stack here, and it's like a container. You can clearly see we'll just use it to keep track of our positions in the nested structure, and it is crucial for handling nested lists. So because we might need to go deeper into the structure before we find a number. Okay, so I have initialized a stack here. Now okay, so let's initialize stack. Now what are we going to do? We are going to keep track of our nested list. Okay, now what are we going to do? We will use the, what are we going to use? We are going to use the next method now. So we are first of all going to check if there's an element in the next or an integer in the next or not. If there's no integer, we'll return null. But if there's an integer, what are we going to return? If there's an integer, then we are returning stack.peak dot next dot get integer, because we have to use the interface. Now, so first of all, let's talk about this next method. So it's like just asking what's the next number. Okay, if it checks if there is a number available, it will return the number, otherwise it will return null to us. Okay, now let's next up is the hasNext method. So what is it going to check? It is going to check while stack is empty or not. While stack is not empty, we are going to check if stack.peak hasNext. Okay, so basically this method checks if there is another number after the current one. So it keeps looking until it either finds a number or determines that there are no more numbers left. Okay, so if there's a next element or the next integer available, it will look after it, and it will return that to us. Now, if the stack is empty, then what are we going to do? In that case, we will iterate through the nested integer okay, so we are initializing a value named nested integer, which will be equal to stack.peak.next. Here we'll check if value is integer. If it is integer, or in other words, you can say if it is not a list, then you are just going to create a list first of all. Okay, list of nested integer, okay, this is your new array list, and you will just add that value to your list. Okay, so you created a list, an empty list, and then I just added that integer value to my list. Okay, now Okay, so basically, first of all, we are checking if the value is integer. If the value is not integer, then what are we going to do? We are just going to get that value from that list of integers. Okay, we will just um, wait. We'll just get that list of integers and we'll iterate through the list. Okay, and then we'll come out of the loop and we'll return false. So basically the thing is, first of all, we'll see how the nested integer, or you can say the nested iterator, we have created an instance of nested iterator, and it will start with the outermost list. If it encounters a number, it immediately gives it to us. Okay, otherwise what is it going to do? It will, if it encounters a list, that is in the else part that we have written, it goes inside the list and it starts, or you can say it continues the process again. So basically, putting it all together, you can say we use this nested iterator in a loop, and in each iteration call the next method to get the next number. If hasNext returns false, okay, hasNext returning false, what does that mean? It means that there are no more numbers left, and we exit the loop, and then in the end we return false. Okay, so let's try running the code. Okay, so the code is accepted. Let's submit it. Okay guys, thank you for watching. Stay tuned.